Imagine waking up, opening your eyes to a brand new morning, but there is no dawn. The shadows in your room, they're exactly where they were yesterday, and the day before, and, well, the decade before that. You walk outside, and the sun is just frozen in the exact same spot in the sky. No sunrise, no sunset, just this permanent, blinding stillness. Today, in this explainer, we're diving into a cosmic mystery that honestly sounds like the setup to a sci-fi thriller, but it's actually a very real, scientifically verified phenomenon happening right now across our galaxy. So what if the sun never set? Here on Earth, we're so deeply programmed to expect that familiar rhythm of day and night that it's kind of hard to even fathom a reality without it. But astronomers have realized that out there in the deep dark of space, there are countless worlds where one half of the planet permanently faces its host star, just baking in eternal daylight, while the other half faces out into the void, trapped in absolute eternal darkness. I mean, it fundamentally challenges everything we think we know about how a planet is supposed to work.
Let's get into part 1, the endless day.
To understand how a whole planet gets permanently stuck like this, we kind of have to strip away our Earth-centric bias for a second. Normally, a planet rotates on its axis while simultaneously traveling around its star, right? Earth takes about 24 hours to rotate once and 365 days to complete its orbit, which gives us our standard day and night. But on a world with a stationary sun, the rotation and the orbit have become perfectly locked. Basically, the planet takes the exact same amount of time to spin once on its axis as it takes to complete one full lap around its star.
Which brings us to part 2. What exactly is tidal locking?
So how does a massive planetary body weighing literally trillions of tons just lose its normal spin and get stuck in this bizarre cosmic stare-down? Well, it's not magic, and it definitely doesn't happen overnight. This is a phenomenon called tidal locking, and it happens when an object's rotation becomes completely synchronized with its orbit. Over enormous amounts of time, the immense gravitational pull from a host star actually creates friction and drag on a planet's rotation. The gravity physically stretches the planet ever so slightly, pulling on its bulges. Over millions or even billions of years, it acts like an invisible brake. It slows the planet's spin down, down, until the rotation perfectly matches the orbital period. And the crazy thing is, this massive cosmic concept is happening right in our own backyard. You've actually experienced tidal locking every single time you've looked up at the night sky. Our own moon is tidally locked to Earth. The moon orbits us, and it rotates exactly once per orbit. Because of that perfect synchronization, the exact same side of the moon always faces us. The moon isn't just frozen in place, it is spinning, but it's spinning at the exact perfect rate to keep one side hidden from humanity forever.
Now, when we zoom out to the broader universe, we see that if Earth can do this to the moon, stars can absolutely do this to their planets. When a planet orbits really close to its host star, the star's immense gravity completely dominates the system. It acts exactly like Earth's gravity acts on the moon. It grabs hold of that planet and inevitably locks it into place. So you get one hemisphere staring into the fire forever and the opposite hemisphere staring into the blackness.
That brings us to part 3, fire, ice, and twilight.
What actually happens when you drop down onto the surface of one of these tidally locked worlds? Well, the geography and climate are pushed to the absolute extremes of physics. On one hand, you have the permanent day side. Because it receives this continuous, relentless energy from the star without a single second of shade, temperatures could become unbelievably high. Depending on the atmosphere, we're talking about boiling away oceans and melting solid rock. Then, on the other hand, you have the permanent night side. Zero direct starlight, ever. It's a world of freezing, eternal darkness, essentially a massive glacier locked in the shadow of its own planet.
That paints a pretty bleak picture, doesn't it? A boiling hellscape on one side and a frozen wasteland on the other? It immediately forces us to ask the big question. Does that mean this planet is completely dead? Is a tidally locked world just an orbital tomb, totally incapable of supporting any form of life? Well, scientists say, not necessarily. There's actually a hidden loophole in this extreme planetary design.
Enter the twilight zone, or what scientists call the terminator line. This is the boundary region, a thin ring wrapping all the way around the planet, exactly where permanent day meets permanent night. It's a realm of eternal dawn or eternal dusk. Right here on this line, the blistering heat from the day side and the brutal cold from the night side could theoretically balance out, creating moderate, survivable conditions.
But we have to be clear here. A comfortable twilight zone is definitely not a given. For this boundary to actually be habitable, the planet needs a really specific recipe. It needs a suitable atmosphere and ocean currents capable of actively transporting heat from the hot side to the cold side. It needs the right cloud cover, the right star type, and the exact right distance from that star. If the atmosphere is too thin, the heat won't move, and the twilight zone totally fails. Scientists have to use incredibly complex models to figure out if these atmospheric engines can actually work in reality. If the conditions are right, though, standing in this twilight zone would be absolutely breathtaking. You'd look up at a strange sky where the star remains forever fixed, just hanging directly near the horizon. You would cast these long, eternal shadows. If you started walking in one direction, toward the day side, the sun would slowly rise higher and the heat would start to intensify. But if you turned around and walked the other way, the sun would sink and you'd march straight into the freezing dark.
Let's look at part 4. Could life survive here? When scientists look for the building blocks of biology out in the cosmos, why are they spending so much time staring at planets that might be tidally locked? It all comes down to the most common type of star in our universe, red dwarf stars. Red dwarfs are a lot cooler and much dimmer than our own sun. Because they're so dim, for a planet to be warm enough to have liquid water, it has to orbit incredibly close to the star. And, as we just talked about, what happens when a planet orbits super close to its star? The gravitational pull is immense, making tidal locking highly, highly likely. But that close proximity introduces a massive threat, creating another really fascinating mystery for us. Can a planet's atmosphere actually survive that intense stellar radiation? You see, young red dwarf stars are incredibly violent. They spit out powerful solar flares and bursts of intense radiation all the time. If a planet is huddled right up close to stay warm, it's also taking those flares point blank. Could an atmosphere, which is the very thing required to make the twilight zone survivable, even survive that kind of onslaught?
Part 5. The TRAPPIST-1 system.
To answer these huge questions, astronomers are looking at real, physical targets. A perfect example is the TRAPPIST-1 system. This is a compact, densely packed star system where our theories finally meet reality. There are exactly 7 known Earth-sized worlds crammed into this one system. It's basically a cosmic goldmine for scientists. 7 rocky planets, all orbiting a single small red dwarf star.
And here's the best part. Several of these 7 worlds are orbiting right smack inside the star's habitable zone. But because the star is a dim red dwarf, they are huddled extremely close to it. This means tidal effects are massively important here. Astronomers are actively using powerful telescopes and atmospheric models right now to investigate these specific exoplanets, to see if they have atmospheres, and to figure out what their twilight zones might actually look like.
And finally, Part 6, the galactic mystery. When you realize just how many red dwarf stars are out there, you start to realize that our solar system might actually be the odd one out. The reality is totally staggering. Our galaxy could contain enormous numbers of worlds with permanent day and permanent night. Tidal locking isn't just some rare oddity. It could be one of the most common outcomes for habitable planets in the entire universe. We might very soon discover atmospheres and biospheres that operate on rules completely alien to our solar system, just clinging to life in the eternal shadows of the Terminator line.
These worlds challenge the very limits of physics and biology, proving that the universe is far stranger than we ever imagined. So I leave you with this final thought. If you had to live on a tidally locked planet, would you choose permanent day, permanent night, or the twilight zone? Tell us your choice in the comments and subscribe to Curious Orbit for more space science and cosmic mysteries.